Need for stabilization. Earlier we have seen the Q point and factors affecting the Q point. Now we are understanding about stabilization and need for stabilization. Before that, what is stabilization? The process of making Q point independent of temperature variations or variations in transistor parameters is known as stabilization. That means we know that the Q point is will changes with respect to the temperature variations. That is, if we look at the factors affecting the Q point, we can understand. That is, if the temperature changes and IC also changes, this IC will in turn changes the Q point, and VB and beta these are also the factors that are affecting the Q point. And thermal runaway is a problem because of the temperature increment. So to make the transistor stable and independent of all these parameters and work properly, we require the stabilization. Now first one, that is temperature dependence. Temperature dependence, we know that IC and VBE are temperature dependent components. That is, when the temperature increases, the collector leakage current which depends on the temperature will increase. That in turn will increase the IC. And VBE, we know that the condition of the VBE, that is, it decreases for every 1 degree raise in temperature, that is at 2.5 millivolts. This is also temperature dependent component. That is why we require stabilization to make IC constant despite of temperature changes. So this is the one point for what we require stabilization. And change in VB and beta, these are the another two main components. That is the beta, which is the gain of the transistor. If the gain changes, then the output automatically changes. For it will not give us faithful amplification. For that, beta must be made constant. That means if we make IC constant, we know that the IB, which is the input current, will be constant. So if we make IC constant, then beta will be constant. So for constant gain also we require stabilization. Thermal runaway, with the increase in the value of IC, the transistor may drained off and it may be exhausted. To make transistor run safely for entire the process, we have to stabilize the Q point. That means it must not transfer into any one of the region. The IC must be constant. That means it must not increase for every increase in temperature or decrease in temperature. So we require stabilization. To know how much stable the circuit is, we have to calculate the stability factor. For that stability factor, we have to know what is stability. Then after we can calculate the stability factor. The stability is we have seen that earlier. That is it is to make to give the faithful output at a single Q point, which is fixed at the initial conditions of the transistor. So that is the stability of a transistor. To calculate the stability, we require the stability factor. The stability factor is nothing but the rate of change of collector current with respect to the collector leakage current, that is the ICVO. That is the rate of change of collector current, that is IC, with respect to the ICVO, is called stability factor. Now the stability factor is denoted with the letter S, and it is given by the DIC by DICVO, that is the change in collector current to the change in collector leakage current. That is, we can also represent this as delta IC by delta ICVO at constant VB and beta. That is, VB and beta must be constant. If we make these two constant, and we can get the stability factor. And to get the stability factor, now let us take this equation, that is IC equation. That is, IC is equal to beta IB plus 1 plus beta into ICVO. with the differentiating on the both sides with respect to IC. By differentiating this equation on both sides with respect to IC, we will get this equation: dic by dic is equal to beta into div by dic plus 1 plus beta into dicbo by dic. We know that dic by dic is equal to 1, and beta ib is transferred to this side, and 1 plus beta into dic by dicbo. We have earlier seen that s is equal to dic by dicbo. We can write this as 1 by s. So we have written that 1 plus beta into dic by dicbo is equal to 1 plus beta by s. That is stability factor. Now if we transfer this s this side and this whole expression this side, s is now we will get s is equal to 1 plus beta by 1 minus beta into dib by dicbo. This is the actual equation of the stability factor. To calculate the stability factor, we have to substitute the ib and ic values of a circuit. If a circuit is less than 25, then it can be somewhat stable and we can get faithful output. If it is greater than 25, we can it is not a faithful circuit. And for stability, if the stability factor